How's it going, everyone? Cup of Science Joe here. I am in a basement now, which is also unfinished, so I'm probably gonna have to get something exciting for the background that I can, hang back here. It'll look cool. I don't know, we'll figure something out. Now that the move is finally complete enough, I wanted to come back and make another video. I'm a little bit late to this party, but I really wanted to talk about the Osiris-Rex mission that just kind of had a big update last month or 2 months ago, something like that. So today, we're going to talk a little bit about Osiris-Rex and what it did. First, what does it stand for? Well, that is Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. Osiris-Rex is the first U.S. mission that collected and returned a sample from an asteroid and brought it back here to us on Earth. Fun fact, Osiris-Rex launched back in 2016. The way they achieved obtaining a sample was via a touch-and-go method, where after a couple of years of orbiting, studying, and mapping the asteroid Bennu, the spacecraft Osiris-Rex made contact with the asteroid, gathered material from it, ahead of breaking away and heading back to Earth. Then comes September 24th, 2023. Osiris-Rex makes its pass over Earth, dropping the capsule of material over its atmosphere, where below, in the desert of Utah, in the Department of Defense's test and training range, the Osiris-Rex team was waiting to collect it. The spacecraft, still in solid operating condition, went on its way for a new mission under the name Osiris-Apex, bound for a new asteroid called Apophis, which it will study and hopefully help us learn even more about the origins of our solar system. As for the material left behind, scientists will be studying it for years to come, which will also hopefully help teach us a lot more about our solar system and its formation, origins, fun stuff like that. Why Bennu? Why was Bennu chosen as the asteroid for the Osiris-Rex mission? What exactly made it so enticing to scientists? Well, Bennu's orbit is close to Earth, and in some cases even crosses it. This is in contrast to many asteroids that orbit between Mars and Jupiter in the asteroid belt. It also orbits on nearly the same plane as Earth. While the task was still not easy, these factors made it a lot easier for the spacecraft to go from Earth to the asteroid and back. Size was also a factor. Like Earth, asteroids spin on their axis, and the smaller the asteroid, the faster its spin. It can get up to a few revolutions a minute, which I think is pretty fast. This rapid spinning makes it difficult for a spacecraft to match its speed and velocity in order to touch down and collect samples. Potentially even more dangerous is that when a smaller asteroid is spinning that quickly, pieces of regolith, which we both wanted to collect, can just fly off the surface, and possibly also into an unsuspecting spacecraft. Bennu is large enough to have a slower rotation of about once every 4.3 hours, which makes it far easier to keep up with, and it is rich in regolith, the material that the Osiris-Rex mission was looking to collect. Bennu is also rather old, being a leftover fragment from the formation of our solar system. On top of that, because it's been in a vacuum for its whole life, the material is very well preserved, making it an excellent target for the mission. The sample return portion has already been successful. Once collected, scientists have estimated that we now have around 250 grams of material from the Bennu asteroid that can be distributed to scientists worldwide for further study. An initial report from NASA's Johnson Space Center also told us that the sample shows evidence of high amounts of carbon content along with water, which are two key building blocks for life. Something else I think is really cool and exciting is a good amount of the sample material will be saved for future generations of scientists and researchers who can study it using technology that, frankly, we don't have yet, and who also are probably asking questions that we haven't even thought to come up with. All of these things are exciting to me, and I find myself eager to learn more results coming from the study of the Bennu asteroid. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.